Welcome students. This is the next topic in your unit 2 in electronic circuits, MOSFET amplifiers. It's nothing but the cascade amplifier as well as cascode amplifier. Cascade means both are coming under the concept of multi-stage amplifiers in MOSFET. Cascade means it is connected the CS with CD. That meaning is your first stage is common source, second stage is common drain. And if it is in the case of cascode, and your first stage will be the common source and your second stage will be the common gate. It is for MOSFET. If it is BJT, your common emitter will be in the first stage and common base will be in the second stage. So as for this configuration, your circuit has to be grown horizontal. So this way it has to be grown. And for cascode amplifier, your gate will be grows vertically. Clear? So then in first stage of cascode amplifier, it is common source, meaning this source has to be grounded and then output has to be taken at the drain terminal for M1 transistor. It has to be connected either through direct coupling, RC coupling, or a transformer coupling. In general, we have connected or normal coupling. Then your M2 transistor is a common drain. So drain has to be grounded while we are analyzing in the AC way, and output has to be taken at the emitter terminal. And for Cascode, your first stage is common source, meaning is you have to taken the emitter has to be immediately grounded and input has to be given in the gate terminal, output has to be taken, and this is connected to the second transistor through a direct coupling. And this M2 transistor is a common gate, meaning is gate terminal has to be immediately grounded and your output has to be taken in the drain terminal. Therefore, it is called as a common gate. And these two configurations is called as a multi-stage amplifiers. Then I have to analyze in small signal AC equivalent diagram. Have to rechange your main diagram into this small signal hybrid by equivalent model. And here voltage source series with the resistor and two resistors in parallel, we call it as RTH. And it is an NMOS transistor. So it may be that plus carries plus for gate symbol and a minus for the source symbol. And for the first M1 transistor, we call it as GMVGS1. And for the second current source, we call it as GMVGS2. And the gate and source symbol, same way, both are NMOS only, have to connect like that. In same way for cascode amplifier, and we have this type of configuration, two transistor which is grown in a vertical manner. Meaning is when I applying the KCL here, your GMVGS2 must be equal to GMVGS1. So finally, our ultimate aim is to find out the voltage gain. For that, we need two answers, V0 and Vi. For V0, you have to see the right hand side configuration. V0, two resistors connected in parallel with the current source of GMVGS2. So this is the portion. Then in same way in V0 for the cascode amplifier, it is a single configuration and the value is minus because the current flow will be in anti-clockwise direction. Always the current flow will be in clockwise, hence it is minus GM1 VGS1 into RD. The next step you have to find the input voltage. For this configuration, you have to first find out what is the value of VGS2. This can be applied by applying the KCL at this node. Find the relationship between your VGS2 and VGS1. After finding the relationship, and then take the formula of VGS1 by voltage divider rule. Then you have to substitute both the answer. Similarly, here for the cascode amplifier, your VI will be equal to VGS1. So hence it is V0 by VI will be equal to GM1 A minus GM1 into RD. So that's all about your cascade and cascode amplifier. Both amplifiers are comes under the category of multi-stage amplifiers. Thank you, students.